This is question number 33 on the January 2017 Algebra 2 Common Core exam, the Regents. And what we have here is an interesting concept, and I'm going to go a little bit into a concept here before I do the solution. It says algebraically determine the values of h and k, which are typically constants, to correctly complete the identity stated below. And the idea here is, let's say I have ax squared plus bx plus c is 3x squared plus 5x minus 7. Well, you could safely conclude that the a is 3, the b is 5, and the c is negative 7. We do carry the negative in the front. So, using this concept, let's do this problem. What we're going to do is get this right side into the same form as the left side. So we're going to distribute out the x minus 4 to the 2x squared plus hx plus 3. And it's a 2 by 3. We have a binomial and a trinomial. So I prefer to use the box method here. I think it's a little bit easier to keep track of all of your terms this way, rather than try to do like an extended FOIL or a double distribution. So I'm going to multiply x by 2x squared. We get 2x cubed. Then I'm going to multiply x by hx. That's now hx squared with only the x being squared. Then I've got 3x. Negative 4 times 2x squared is negative 8x squared. Then negative 4 times x hx, so minus 4hx. And then negative 12 here. So we can now say that 2x cubed minus 10x squared plus 11x minus 7 is 2x cubed minus 8x squared plus hx squared, and we could put it in either order, minus 4hx. Let's move this down a little bit here. I'll move it over at least so we have a little bit more room. Minus 4hx plus 3x minus 12 plus k. The plus k is still here, right? That was not part of our original work, but this part right here has now been simplified to this. So let's take a look here. We have our coefficient of x cubed, which is 2, and our coefficient of x cubed here is also 2. That's good, but it doesn't really help us solve anything. So let's take a look at the coefficient of x squared. The coefficient of x squared is negative 10. So we have negative 10x squared must equal the coefficient of x squared on this side using this concept. So what we have is hx squared minus 8x squared. And you could either divide the x squareds out here or add the 8x squared first. It does not really matter. I'm going to divide all the x squareds out. And I'm left with negative 10 equals h minus 8. Add the 8. And what we got is negative 2 is equal to h. Now that makes a lot of sense here because let's say I put negative 2 in here, right? If I put negative 2 in here, I get minus 2x squared minus 8x squared. Well, then my check would verify that I get negative 10x squared. And in order to have both of these sides equal in an identity, all of the coefficients must be the same, so that checks out. And we could also verify it using this term, but now we've already found h. So we could certainly use that to double check our answer if we'd like, but it's not really necessary to solve for it again. So let's say I put in the negative 2 here, and what we get is positive 8x plus 3x. Well, that would actually be 11x, which matches to the 11x here. So that works out, and again, it's just a second way to verify that your h is good. Finally, what we have at the end is a constant. And note that the constant here is negative 12 plus k. Neither of those has an x attached to them. That must equal negative 7. So negative 7 has to equal negative 12 plus k. And what we can do now is add 12 to both sides, and we've got 5 is equal to k. And now we're done. And again, we can verify this. If I put in the 5 here, I get negative 12 plus 5, and I get negative 7. Well, that matches the coefficient, or excuse me, the constant on the left side as well.